Right, so my name's Andy. I work at Lindorf rather than Arado, and I'm here to talk about strong typing, or the lack of it. I have two main areas that I want to talk about. The first one is software configuration. All too often I see this kind of thing in the code base, which at first glance looks fine, but if you've got a very large project, you'll be looking through and then you'll have conflicting naming types. One of those is right, maybe. Or was it actually a connection string? I don't know. There's also other problems with this. What data type is coming out of that? I mean, it's called URL, but it could be an IP address, or it could be an actual URL, or it could just be the name of some guy to go and talk to ask where the service is, or anything. So you could get casting exceptions when you hit this piece of code. But you might not hit this piece of code until your software's been in production for a long time, especially if it's something that does error reporting or causes service in an exceptional circumstance. You also have great difficulty refactoring this. I mean, these names are, well, fairly generic, but if you have good key names, then you can probably find them with grep or any other search tool. But if you've got something generic like, I don't know, remote service, well, good luck finding that. There's probably quite a few of those in your code base somewhere. And the last point is visibility. We certainly have the occasional internal library which relies on values coming from the configuration manager. And you can't tell from using that library that it's going to try and reach into an app config file, and then that blows up at random. So I really don't like this. The static typing as well, how can you test this? Because you'd either have to write to the app config file and read it back, and that's slow, because reading the first hit of reading an app config file is very slow. So you might as well try and avoid that. My solution to this problem is this. We just have an interface with the properties named and typed as what they should be. In this case, we've got a URI and a timespan, and a single implementing class that's got all of that assignment and casting in its constructor. Construct the class once on startup of the application, and any configuration errors you have will instantly explode, and you'll be able to fix those and move on. You've got typing, so you can follow through your code by finding references on iConfiguration. You know what types are going to come through the type system. And if you've got libraries that say require just the endpoint property of this one, create another interface called, I don't know, magic library requirement configuration manager, and implement that as well. And now you can find where your configuration flows through. The only downside I have to this is all of the typing involved. I don't like typing, despite being a programmer, and especially when I have to use a Finnish keyboard, because I'm English and you are all heathens with your keyboard layouts. So I have written a library which does the bottom part of this for you. So you just have a single extension method. The library is called Strong. Use it, don't use it, I don't really care. It's on NuGet. You can configure a ton of stuff with it, and it assigns properties based on convention. I like it because now I don't have to type, and I still get all of my strong typing guarantees from configuration. So that's my rant on configuration objects over. The next thing is primitive types. Stop using them. Let's go on straight onto the example. Sorry, there is a black line across that. That says merchant if you can't read it. So we've got two classes here. They probably have a lot more information in them. Both have got IDs. Both are integers. I mean, your IDs are stored in the database as either, or probably unique identifier or integer. But your identifiers are not unique identifiers, and they're not integers. A merchant ID is different from a customer ID, especially if they're integers. Customer number 4 is probably a very different person from merchant number 4. But because you've got them typed as integers, if you've got a nice query object here, we've got two versions of it here. One takes in the merchant ID and one takes in the customer ID. One of those is a valid call to make. The other one is going to bring you back some interesting data that's probably not related. But you can't tell which is which without IntelliType, if you've named your ID parameter correctly, whereas actually in the interface it's just called ID. It could be anything. You could use named parameters to make it a bit more expressive. But why bother? Why not get the compiler to shout at you? Make it so that only one of these actually compiles. Now, unfortunately, we're in C#, which means we can't do this, which would save a lot of typing. Typing, not typing. Yeah. But you can't do this in C#, and they don't seem to be wanting to add this as a feature. You can do something similar to this in F#, which alleviates all your problems straight away, but you're then in F#, so pick your battles. My solution is to use a structure. Just wrap an integer or a GUID or anything and use this as your parameter everywhere. I mean, this won't work on its own. You have to implement all of the niceties, like IEquatable, operator overloading, serialization, probably to JSON if you're going to expose this somewhere like an API or store it in a database. If you're using Dapper, you'll need to implement a SQL type mapper for this as well. You can make a generic way to do it, but again, it's a lot of typing. But for all of that typing, now only one of these will compile. You've got no danger of ever accidentally trying to load a customer order with a merchant ID. It's just not possible anymore. With your APIs, you tend to get integers and strings from Web API or whatever. Convert them. That's the first thing that you do when they come in is convert them into your types. But we can take this further. It's not just IDs that need typing. So, domain typing. This is where we can start making more use of types. So if we have a person object, name, date of birth, address, using primitive types, is that valid to do? Someone born in 1743 would be 273 years old. If you're a web shop, that's probably not a valid person, unless you're selling anti-aging products, in which case, maybe. But if you're running family tree software, this is probably valid. Probably, I don't know. Depends on your domain. What about this? I mean, email addresses are strings, but that doesn't necessarily mean a string is an email address. Although, interestingly, if you add one @ sign to this, it's technically valid. I'm not saying you should do it, but... So, in the same way as our identifier types, we have an email class. We have a regex, which I'm going to leave up to you to implement, because no one... Exactly. I like regexes for email validation. The regex I use says some text followed by an @ sign followed by some text. I really don't care about anything else, because there's a difference between a valid email and a verified email. A valid email is a hard thing to answer. A verified email is an easy thing to answer. So we can build it into our types. This at the moment is just going to make sure your email address is an email address and you don't accidentally put the word Dave into it. But we can make this a domain concept and make verified emails a different thing to an unverified email. So if you make it abstract and add this, I can do pointy things for this, can I? Not that it shows up on the screen. Okay, never mind. So we have an abstract is verified. Implement it. We now have an unverified email. This is exactly the same as what we had before. It's just using the regex. We can now also create a verified email address. This here requires a verification service, which is probably some kind of dictionary or a lookup table to say whether someone's clicked a link in an email that they've received to say that this is a valid email. But note, you can only create a verified email with an unverified email. You can't just take a string and say, this is now a verified email. You have to come from an unverified email. And obviously, it's verified true. And now Really shouldn't put things in the center of the screen, should I? Now we have two different functions here. One of them only works with an unverified email. The other one works with a verified one. We can now separate our concepts with this kind of email can only go to people who haven't confirmed their accounts. This kind of email can only go to people who have confirmed their accounts. Obviously, if you've got an email that goes to both, just take in the email address class. Now, this has been quite a lot of typing about typing. I really need to come up with another name for this. Keyboarding. This has been far too much keyboarding, in my opinion, but we are limited by what we can do with C#. You can use F# based assemblies. I've seen that done quite a few times. It is a bit more mental overhead, but it's probably worth it because you can prevent a lot of errors from creeping into your system. So I guess in conclusion, strong type all the things, maybe not everything, but at least think about it. That's it. Any questions?